Hi friends, in this video we are going to discuss about the transfer function of a negative feedback control system. So before we are going to enter into the actual concept, first we are going to discuss about what is the definition of transfer function. Here, what is transfer function? Here see, the transfer function of a control system is defined as the ratio of Laplace transform of output variable to the Laplace transform of input variable, assuming all initial conditions to be 0. So here G of S is equal to C of S divided by R of S. Here C of S represents the Laplace transform of output. The Laplace transform of output divided by R of S means the Laplace transform of input. So this is the formula we are using to calculate the value of transfer function. Okay, so this is the transfer function definition. Once again I am defining the definition of transfer function. So the transfer function of a control system is defined as the ratio of Laplace transform of the output variable to the Laplace transform of the input variable, assuming all initial conditions to be 0. So here G of S is equal to C of S divided by R of S, where C of S is equal to Laplace of output divided by R of S means Laplace of input. Now here coming to the block diagram of a negative feedback control system. Okay, so here negative feedback control system is always identified with the help of the sign we are using here. Just see here, this is the negative sign and this is the incoming to this particular summing point. So that is the reason why here minus sign we have, and here the sign of the input is plus. So that this is plus and this one is minus. And here G represents the gain value, H represents the feedback value, and C of S represents the output, R of S is the input. Now see here, so here R of S is the Laplace of input, C of S is a Laplace of output, but we required actual input and actual output. So that is the reason why what I am doing, again I am redrawing this block diagram with the help of the input and output. Now see here, so this is the summing point. So here R is the input having a positive sign, and here we are having the value of gain, we are having the value of gain, and here for example I am considering this is C, and we are using negative feedback, so that this is minus sign, and here this is the value of H, and from this point we are feedbacking to the input from output. Okay, so here this one is the actual negative feedback block diagram. Okay, now see here we are applying R input here and C is the output, and with the help of this feedback system, negative feedback system, the C is directly multiplied with this particular H, so that the output of this feedback block gives CH. So here CH is the input for the summing point. Now R is the positive sign, CH is the negative sign. With the help of this summing point, you will get R minus CH. Okay, R minus CH is the output of this particular summing point, and this value is coming to the input for the gain value, so that we can write the R minus CH into the value of G. Now this complete path is this complete value is the output of G, and this value is a incoming for this particular output. Okay, so here incoming for the output is R minus CH into G, and here C is the output, and C is directly going and comparing with the input to reduce the error value. So with the help of this one, what I am doing, with the help of this particular output and input, we can write, so output C is equal to R minus CH into G. Okay, just I am highlighting this point because R minus CH into G is the incoming for the output and C is the output, so that here output C is equal to R minus CH of G only. So that is the reason why I am writing here. Now see here, so C is equal to R into G, it will gives RG. Next minus CH into G, it will gives what? C into H into G. Okay, Now here we have C and here we have C. Now I am writing this expression like this. C plus CHG is equal to RG. Okay. So what I am doing here, I am taking common C, then 1 plus G into H is equal to R into G. Okay. Now we know that C is the output and R is the input. Now we require what? Output by input. So that we can write, so C divided by R is equal to G divided by 1 plus G into H. So this is the transfer function of a negative feedback system. Okay. So here T of S is equal to C of S divided by R of S. So this complete value represents the transfer function of a system. That is the reason why the transfer function of negative feedback system is always given by, so T of S is equal to G of S divided by 1 plus G of S into H of S. Okay. For example, if it is a positive feedback system, then instead of this plus you will get minus. Only this is the difference. So thank you so much for watching, and please do subscribe my channel for more updates. Thank you.